Hi, and welcome to the Distributed Systems, Terminology, Common Concerns, and Available Solutions crash course. This chapter is What is a Distributed System? I am Kobi, and I say, let's get started. Here is my personal definition for a distributed system. Distributed systems are systems in which functional behavior actors, resources, and the transition of information and resources among these functional behavior actors is performed among multiple localities. If we were to consider a common diner, we could think of the following functional behavior actors. To begin with, we have the host or hostess, which welcomes us at the diner entry and walks us to our table, located at the dining hall. Then, a waiter approaches our table and offers to take our order. The waiter then takes our order and passes it forward to the kitchen, either by typing it in a computer or physically by taking the written order and placing it on a dedicated order board. In turn, the cook collects the order and prepares the meal. This of course happens at the kitchen. Once the meal is ready, he signals to the waiters, which can then collect the meal and serve it to the relevant table. Now, what we've just described is a distributed system. We have a general activity, let's call it dining outside, in which we observed the following functional behavior actors: the host or hostess, the waiter, and the cook. We also noticed the following localities: the diner entry, the dining hall, and the kitchen. With regard to resources, we've noticed the guests, the order, and the prepared items. Finally, we've noticed the transition of information and resources among the different localities, such as walking the guests to their table, or bringing the prepared meal items to their table. As it turns out, it's not so difficult to understand the concept of software distributed systems once we understood the aforementioned terms. Yes, the functional behavior actors will be different and the resources will be called something else, but in general, the general idea is similar. And that is not surprising, by the way, as software systems are mostly created to assist in solving real human problems, and they tend to be created by humans, who generally think in the terms they are familiar with. However, an important distinction has to be made here. In software systems, when we say functional behavior actor, we usually refer to a system process. A system process is an operating system resource local to a specific physical machine. The system process is responsible to perform program code at a specific order and has dedicated resources, such as memory, assigned to it. Hence, distributed software systems tend to be code pieces, in many cases implemented in different programming languages and frameworks, distributed across processes hosted on one or more physical machines or one or more geographic locations. Let's consider the next example, this time from the domain of software systems. I will start with a simple example, and in the following videos, as we become more confident in our gathered knowledge, I will present more sophisticated examples. A website is being hosted on a web server located in Brazil. That means that any client trying to access the website types the address of the site in its web browser, and the call is being made to the web server located in Brazil, which in turn responds with the content being displayed on the client's web browser. As the site gains popularity, the web server is being accessed by more and more client requests to serve content to them. In turn, the web server, trying to respond to all requests, will begin to serve content slower and eventually will even crash under the load and the entire website will become offline. At this point in time, our web server is being a single point of failure, a term which we will dive into deeper later on. In general, this means that the entire logical system of our website depends on its physical capability to serve content to clients. What if we present an additional web server located in Japan, for example, serving the exact website content to the system? Theoretically, assuming the exact same capabilities for the new web server, we double our website system's capacity for content serving. However, here we encounter an interesting issue, which is termed coordination, and will also be addressed thoroughly later on. When a client is typing the website address in its browser address bar, how does the browser know from which web server to request the content it desires. Client requests need to be coordinated so that they are being shared among the web servers we have in our system. One way of achieving this goal is by introducing a load balancer, which is a system process dedicated to the sole task of passing incoming requests to a specific web server. Load balancing will be given a very special consideration in this course as well, and will actually be related to almost any aspect discussed, as managing higher loads of data is probably one of the most influential concerns when dealing with distributed systems. To summarize this short video, we've covered the term distributed system from a very high bird's eye view. It was clarified that we generally consider a system to be distributed when it has functional behavior actors, resources, and transitions being performed across different localities to achieve a desirable larger functionality, such as serving dinner to a party or serving a popular website to multiple clients. I hope we all better understand what a distributed system is, and I'm looking forward to hearing from you in the comments section. Don't forget to subscribe to the channel so you don't miss out on the next video in this Distributed Systems, Terminology, Common Concerns and Available Solutions crash course. See you soon.